So let's begin recursion and DP. So recursion in general, a very simple, like it is a very important concept. पूरा बेस है डीपी रिकर डीपी ग्राफ्स एवरीथिंग फॉरवर्ड बहुत सारे क्वेश्चंस सिंपल रिकर्जन से भी हो जाता है लाइक लॉट ऑफ क्वेश्चन इन फॉर एग्जांपल कोड वीटा हैकर का मेजरली रिकर्जन बेस्ड ही होता है बहुत इम्प्लीमेंटेशन बहुत रिकर्जन लाइक बहुत इम्प्लीमेंटेशन बेस्ड बट जस्ट सिंपल रिकर्जन डीपी की भी जरूरत नहीं वैसा क्वेश्चन भी आता है बट you have to think of recursion and you have to write that entire code out, right? So I'll basically be guiding you to how to think of recursion, how to get the base cases cleared out, how to make the transition states and stuff. उसके बाद we'll move on to deep. So recursion in general, if you want to think about it, if you are like myself and can't visualize your code or you can't like see what is happening like in your mind, like I'm not a visual person, so you can think of it as some kind of black box. Okay. What it does, you give it, let's say, input state. Okay. Some magic happens and you get all possible answers. Okay. So that is the output, input and output. Now, answer can be one answer, lot of answer, like all possible answers in the sense count number of something or check if like print yes if valid something like that or
आप प्रेजेंट कर रहे हैं
हाँ वो दिख नहीं रहा है कुछ भी।
म्यूट कर लें ऋषभ ओह ओह सॉरी माय बैड हाँ अभी दिख रहा
हाँ
हाँ
सॉरी सॉरी हाँ so basically think of recursion as a black box. This is recursion. I'll also tell you how to visualize it also, but huh. Currently, if you don't know, think of it as some magic function which you give it an input state and it generates all possible answers. It goes to all extents. Whatever possibilities are there, it goes everywhere. And what it does is, let's say you want to count number of something, like number of factors, or you want to print if it is valid. For example, if it's a prime number or not. Like this is a very basic part, but prime numbers and factors is a very basic thing, but this in general is what is used during recursion. Or if goal state is achievable. Okay. Okay. Now, how does this like what does this black box and how does it kind of work? Okay. So basically, let's say I want to okay. Let's say I want to generate just the number of uh, okay. So now let's say there is a grid over here. This is a grid. Okay. There is a block here. Let's say there is a block here. A block here, and you have this goal, and this is your start. Okay. Now you want to see if I can reach the goal. Okay. Now, how would you do it in your mind? You would try to go to some direction and follow, and you find the goal here, right? This is how you visually do it. Like for example, any maze kind of thing. What you do is you try out some answers. Like you follow some grid. If you, let's say, reach a dead end over, this is a dead end. So if you reach here and you can't go anywhere else, you go back and then you go to the goal, right? You choose a different direction. So that is what recursion is basically. Now, just like your mind does it, you what recursion does is, let's say you have a you have a start state. It goes to, it has some possible states it can go to. For example, it can go right, it can go down. If there was an up, it can go up. If there was a left, it can go left. So these are the states it can go to. Now here, let's say this it goes right. Now what happens is the person has moved, right? So my person is here, my goal is here, and the blocks are still there as it is. Now you just continue this process. From here, there is more states. And let's say this is the dead end. This is the dead end. And this is you reach the goal. Now, if you want to count the number of states, you reach the goal and then you, let's say you go to the different state. Let's say you figured out, okay, this is true. Now, for example, you've moved like this. This is a valid path. Now you want to count the number of states, so what do? You go to a different direction also. So in this branch also, you have states. So here you go down. Now going right is just dead end, and going down again, you have more states. So this just goes on till you find the valid state and you say there are two paths. Okay, that is like that is the end, like that is the gist of how recursion works. Basically, you can think of it like a tree. Okay, you have a root node and you have branches. Each node has a branch. The number of branches and everything is up to you, how it will go and stuff. Does this make sense?
Yes.
Yes.
Cool. Yeah. So now how do you come up with the code and stuff, right? Now another very famous example of recursion is factorial. Basically, I want to calculate 5 factorial. 5 factorial is what? 4 factorial. 5 factorial is what? 5 into 4 into 3 into 2 into 1. Correct. Now, if I want to calculate 5 factorial, what is this part? It is 4 factorial, right? So instead of looping from 5 to 4 to 3 to 1 and keep multiplying, what I can do is simply factorial of 5 is 5 into factorial of 4, right? Now, same thing, factorial of 4 goes to factorial of 3, then it goes to 2, then it goes to 1. Now, since I already know 1's factorial, I just return 1 over here. That is a base case. So, what is this called? A base case. Same thing over here, reaching the goal, reaching goal or out of bounds or hitting block is base case. What is a base case? Base case is basically I already know what to return. Okay, that is a base case. Why is this necessary? If I don't, if I don't stop here, what will it go to? It'll go to 0, then it will go to -1, and it will keep on going till minus infinity. Right? Since I already know this answer, why should I go down? Like there is no other state like zeroth you can count, but -1 and forward, there is no factorial only technically. Like there is a gamma function, but yeah, factorial hai hi nahi. So I should just stop over here, right? Same as over here. If I reach the goal, do I need to go further? No. If I'm out of bounds, that means I'm invalid. I can't go to this state only. If I'm hitting the block, same thing. I can't go to the state. So that is a base case. I don't visit that part, or this is an invalid case, or I know the answer. That is the main thing. Make sense? Hello.
Yes.
Yeah. So now coming back to like just summarizing everything, I need recursion, visit all possible states from current state. Okay, that is the entire tree path. And what is the second part of this recursion? Know the base case. Sys. Okay. If you know these two things, like if you know these two things, then recursion is done. Okay. You just need these two important things. Then you can write any recursion however you want. Time complexity, I'll come back to this later. But currently you can just fix this. Okay? Make sense? Now let's come to the code part of it. Okay? So let's make a void recursion. I'll zoom in. Okay. Let's say there is some, wait, instead of this, okay. Let's say I have some number over here. Okay. Now, there is two important things, base case and next states, or it is also called as transition states. Okay. Base case, for example, in factorial, what is a base case? If number is less than equal to 1, I return 1. ln or int whatever. And in factorial, what is a transition state? Return number into factorial of number minus 1. That is the entire factorial part. Now, if you want to see 1, 3, 2, 4, 5. So 2 factorial is 2, 4 factorial is 24, and 5 factorial is 120. So this entire thing works. Now, some very important things while writing the base case. Okay. If I would have just written this, okay, I would have gotten TLE. Can anyone explain why? Like it is a very common thing. People might mistake this lots of times. It happens. But why will this give wrong answer TLE whatever? Can anyone
Because
tell?
factorial of 0 is also 1.
Okay, I'll also write this. Number equals 0. Now also this might give a TLE. Why? If I just submit this code, I don't know the constraints. I'm just like constraints, it doesn't matter. But let's say not even TLE, I'll get, I'll just tell you, if my number is minus 1, I'm just inputting a number randomly. No? If I give this factorial a negative number, what will happen? It will go infinitely. I will not get the answer only, right? So it is very important to just make sure that all the cases are handled over here. Even if I by mistakenly pass a minus 1 or a negative number, I like in general in CP questions you will get the constraints, right? But if you overlook the constraints or you are doing some like dev related thing, you're using a recursive function, all the cases should be handled. Even if some unwanted state is happening, I need to give it in a base case. Like either this or if number less than 0, just wait, either this or you can do number less than 0 assert. What it does is it raises an error. However you want to handle it. So that is the main thing. Whenever writing a recursive solution, since it is going to all states and you don't have the control, the only control you have with recursion is the base case. This goes on its own. Okay. The entire control of this function or this entire recursive state is with your base case. If you miss out some case, it will go on infinitely and you'll suffer basically. You won't know what is wrong with your code. A lot of times it happens. Let's say you've written 100 lines of 50 lines of a recursion function and you missed out a base case. When you're running, you won't notice. It's very hard to debug. So whenever writing a recursive function, always write a base case first and make sure that base case is correct. Make sense? Yes, no. Hello.
Yes.
Yeah.
Yes.
Now coming to the grid thingy, grid question. Let's say I have a recursive function, void recursion. I have grid. What does this tell me? That this is a grid. Grid is this entire thing. I don't care where I am right now. Okay. The position you are at right now comes from this part of the like I and J, basically the row and the column. If I always, if I change this grid every single time, like you can do that. There are things of changing the grid as well, but this is a very easy thing to do because if I don't have this, then I'll have to find the current cell, right? I'll have to loop over once again. Why do I need it if I already just pass it directly, right? LLI and LLJ. Okay. What are the base cases in the find path function? What are the base cases? Can anyone tell me?
out of bounds,
Hmm?
like
Out of
the
bounds, yeah.
cell is not
So
cell is
first,
not blocked.
base cases. Number one, out of bounds. So what do I write here? Let's also firstly n equals grid top size, n equals grid of 0. Basically, I'm getting the number of rows and number of columns. I can write it over here. And basically, this is out of bounds that I less than 0. Boolean. I greater than equal to n or j less than 0 or j greater than equal to n. I return false. Correct. What is this? Next thing, block.
Blocked, blocked.
If grid of ij equal to, let's say, hashtag, then return false. And what is the last state? Goal, right? If grid of ij equal, let's say g, return true. Correct. These are the all the base cases. Now, what are my transition states? Hello, can you tell? What are my transition states?
You will try moving like adjacent.
Yeah. So now here it is. Move to next cell. Okay. So how do I move to the next cell? Either I'll go left. So let's say bool answer equal left is what? Find path grid I comma j plus 1. Correct. And then what is, let's say, down? This is right. Sorry. Down is find path grid of I plus 1j. Left is find path grid of I comma j minus 1 because I can go left. And up is answer or equals find path of grid I minus 1 comma j. Correct? Yes, no?
Yes. What is the main aim? Like to check if we can make it or not.
Return answer. Another. Now, one more thing. Harsh, I think, pointed it out also. Just writing this base case, I'll get an infinite loop. Why is that? I've missed an important base
By
case.
repeating
Harsh, your voice is breaking. I'll just tell it to
Repeat it.
others. Your voice is not clear, Harsh. But take. Now, since the grid is like this, can I just keep on doing this? I'll just circle around, right? I will never reach. So, what are my base cases? Will I reach out of bounds in this thing? No. Will I reach a block in this loop? No. Will I reach the goal? No. So, what will this keep on doing? I'll just keep on moving in a circle and it'll basically be an infinite loop, right? So, that is why the base case is very important. That the fourth base case, don't visit again. So, for this, you will require another thing and visited if visit uh, vector bool visited of ij return false. Now one more thing. Um, just copy. One more thing. Now since I know it is not visited, I also need to write. I also need to mark this state as visited. Okay. So this is a very important thing in any recursion kind of thing. You always like you most likely never visit the same thing again. Now this part is a bit different thoda. That part Danish sir has come to he'll explain in graphs more in depth ki why this works and what happens to the time complexity. But in general, this is what a recursive code is. Now, if you want there is a very neat trick over here. Instead of doing this, writing four different functions, you might mess up. You can what I do is I make this vector. Okay. Now what I can do is k equals 0, k less than 4, k plus plus. Bool answer equal false. Answer or equals find path grid I plus moves of k, j plus moves of k plus 1 and visit it. That's it. You are much less likely to make a mistake if you do this. What it does is basically it goes to these pairs. And what do you see? Minus 1, 0 is going up, 0, 1 is going right, 1, 0 is going down, 0 minus 1 is going left. Okay. So this is basically a tip for these kind of questions. If you can move diagonally also, you can make a vector LL diag, which is basically minus 1, something which I don't remember. I'll give it to you.
Guys, here, there only you can add a minus one.
You can use two loops and stuff. Whatever. So that is a very important thing. These are the base cases. And another thing, yeah. If I change the order, what will happen? My grid this will return an error. I'll go out of bounds while trying to get this cell, right? Because I have not made sure that I and j are within the bounds. So that is also important. The order of everything matters. Like you can shuffle this around, but this out of bounds check always try to put it the first because all the other checks happen based on the out of bounds with the assumption that it is not out of bounds. Correct? Yes, no. So now I'll like recursion is basically done with. I'll pass it. Good. So now what I need you all to do, Abhi, since I have just told you this is the entire format of any recursion. So any recursion code, what do you do? You write a function. You have some states over here. First is base case. Then you have transition states, and then most importantly, return. Return something. Return answer. Okay. If my if I want to count, what would I change over here? I would just instead of or, I'll do plus, and I'll change this. Make sense? So whatever you want to find the answer of, that on that basis you change this part. Okay. Now some transition states you might need if conditions beforehand. Like there is something you can either have everything in the base case or I do an out of or I do out of bounds check here. You can do either or, that is up to you. Doesn't really matter. The time complexity and all remains the same. Now, for to practice recursion, you can do a lot, but I would suggest going on LeetCode because it has very standard and very good recursive problems. You just sort by difficulty and just solve these like linked list and stuff you can avoid. But yeah, this question, where is Queens? I'll also make a doc with all the important questions. But some important questions are in Queens. Over here, transition states is hell. Okay. So if you can write this part, it'll help you a lot. And N Queens is actually in your portion in the fourth semester. So they'll ask you to write this N Queens code. They like it'll come in the paper, even in the end sems will come. So अभी से कर लो तो easy हो जाएगा like entire
जस्ट अ
DA होगा.
क्वेश्चन
इसमें इसमें जो
अगर हमारा कोड टीचर्स को नहीं समझा नेक्स्ट सेमेस्टर तो क्या
हाँ,
तो लाइक
that thing has happened to me. So what do you do in that case? For example, in N Queens, my code, I'll just show you. किधर है? किधर तो था रुक दिए हुए हाँ
इसमें 3 arrays बनेंगे ना
हाँ
डायगोनल्स का भी बनेगा।
डायगोनल्स का बनेगा एंड
हाँ
कॉलम का
एन
बनेगा।
क्वींस।
हाँ।
तो ये मेरा कोड है। ओके, टेक्निकली वो बहुत बड़ा लिखा है बट इट इज अ
हाँ,
वेरी, दिस इज द एंटायर लॉजिक।
बट इतना लॉजिक नहीं है, 4-5 लाइन में हो जाता है कैसे।
नहीं नहीं वो पता है, लाइक दिस इज द मोस्ट ऑप्टिमल पार्ट, बेसिकली दिस इज द मोस्ट ऑप्टिकल एन क्वींस सोल्यूशन काइंड ऑफ, बिकॉज बहुत सारा स्टफ है, लाइक आई डोंट नीड टू
क्वेश्चन
चेक
एक बार बता
डायगोनल्स एंड
सकते हो?
स्टफ। हाँ
क्वेश्चन
हाँ,
डिस्क्राइब।
क्वेश्चन डिस्क्राइब कर लेता हूँ। तो यू हैव चेस बोर्ड। Okay. The size of the chessboard is given in the question itself. That can be a 2 by 2, 4 by 4, 8 by 8, whatever. A very standard thing is 8 queen. So, yeah. Now, what you need to do is place 8 queens. Like, fill the and every row should have one queen, every column should have one queen, and no queen should attack each other. So, let's say I place a queen over here. That means I can't basically place a queen in the diagonal, in the row, in the column. So now the next queen I can place over here. Next queen I can place over here. I can place over here, and I can place over here. So that
लाइक
is
ये
the,
ग्रीडी नहीं हो गया कि मतलब हॉर्स जैसा चलता है वैसे उधर से।
हाँ greedy type ही है. Recursion is basically I am going to all the states. Okay. Now can I place a queen here? No. Can I place a queen here? No. Can I place a queen here? No. Directly I move on to this, and then it. Now if this was not a valid thing, I'll start from here. Same thing. Recursion, it handles everything with itself only. So now what do I
लाइक
need to,
ये विदाउट
huh?
विदाउट रिकर्जन नहीं कर सकते।
Without recursion, you won't get all the possible states. Like you might get one state, but if I want to count the number of n queen solutions, or and without recursion, it'll be hell. Like you'll have to do lot of stuff. So
लाइक वी प्लेस लाइक हाउ द हॉर्स मूव लाइक 2.5 वी प्लेस देयर ओनली।
first row, then second row and stuff, right?
Yeah, like first we put then how the horse moves in each position.
Lot of things you can do. Everything works. Like recursion is like a very simple thing to do. I feel recursion is easier if you feel for loops or looping the entire thing is easier. Very well and good. Viram loves iterating the entire DP stuff. He just does it with for loops. So if you want tips for loops, Viram is the best person to ask for it, which you know. But now recursive state basically over here, my my base cases I'm handling over here itself. And what are the my visited array or my places where I can't places. If I have placed a queen in this row, then I can place it. I can't place it on that row. If I have placed it in this column, I can't place it in that column. This is a diagonal ka thing. There is some, it is some logic, but basically diagonal ka you can, there is a thing I'll explain later a bit, time nahi hai. But diagonal ka visit, I can just make this array. That's it. So when I'm placing, I just mark that diagonal visited and then mark that diagonal unvisited later. That is also a very important thing. So now, in this question, I really messed out. But after I've done everything, I need to mark this as not visited if I want to count the number of states. Why is that? Because let's say there is a path like this and there is a path like this. Okay. If I already mark these visited, I will never count this path because it will come in visited. So that is why Huh. Why is this important? Like, why am I then marking it and then demarking it, right? You might have a question. For example, like the logic for marking makes sense कि infinite loop में नहीं जाना, infinite recursion में नहीं जाना. But why am I not marking it again? So now after I've computed everything, after I've visited all the paths starting at this cell and coming from this cell, I know for sure कि वापस सेम स्टेट पे पहुंचूंगा नहीं. कि for example, I have done this and let's say this is an infinite loop wala case. Now I'm going back. But since this is visited, I will not go to this cell. Fair enough. But and then I find a path over here. Cool. But now if I mark this everything as visited, this path won't be considered. That is why once I've computed a path, I've visited all the state from going here, basically. I mark this as unvisited. That is a very important. Like I am saying it, thoda it is not making sense. But when I'm counting paths, always mark it back unvisited. In a pure recursion or a state thing, DP में ज़्यादा optimization आता है, but this is that it, right? Make sense? Hello. Doubt हो तो भाई बोलो. Hello. Huh. Yeah. So now coming to the time complexity, a very I'll just touch on this. Usually in a recursive solution, TC is number of transition states raised to all possible states, like or number of visited states. Number of visited states at what else? Uh, क्या आता है? Number of transitions raised to total number of states. Okay, so that is it. So over here in this case, what are the number of transitions? I have 4 transitions and visit like there can be a state where I visit everything. No, I can't visit more than that. Correct. My worst case is I visit all the cells. So in the example of grid, my TC is 4 raised to n into n. Okay. And in factorial, TC is uh, well, exponent. Sorry, this is not counted. It is 1 plus. My bad. ये थोड़ा इधर 1 ऐड करना पड़ेगा. So here this is not 4. You can assume it as 5, but usually all these don't work. Like उतना time complexity like TLE ही देगा. And 2 raised to n because maximum I'll go to n steps. Got it? In general, if you don't want to calculate like this, like there is more to this. It's not just that. Not just this. It gets complicated. You will have this in your analysis of algorithm वो सिखाएंगे. How to actually calculate the O of whatever. But in general, there are some theorems and stuff. बहुत complicated हो जाता है. But in general, you can just assume it is exponential 2 raised to states. If I want to calculate, in general, I would assume it is this. There are obviously more nuances to it. बहुत सारा वो आता है. You will learn it in your semester अभी time है. पहला I think first or second module is just that. So backtracking तो आ जाएगा तुम्हें, don't worry. डाउट हो तो मुझे पूछ लेना कि भाई ये समझ नहीं आ. But it gets complicated. TC. That was why I was not touching into TC that much. But in general, you can just assume it is this. Like assume it is this because this is related to the DP solution, DP ka time complexity. This part remains the same. This entire part remains the same. That is why it's just better to keep it like this. Fair enough? Yes, no? Cool. Now let's start with DP. So yeah, DP is basically dynamic programming. People might be scared of it. I was too. Don't worry. I'll explain it very in very simple terms and the way I understand DP or how I visualize, not visualize, how I write code or how I think of DP at all. Okay. So now, what is the problem with recursion? What is the problem with recursion? फिर बोलो भाई. हेलो. हेलो हेलो. आवाज नहीं आएगा तो मैं कंटिन्यू कैसे करूँ? थोड़ा एक्टिव रहो. अभी तो मेन टॉपिक है.
रिलेटिवली मतलब थोड़ा स्लो है.
क्या क्या? हाँ स्लो है करेक्ट. बेसिकली
और
हाँ
लाइक स्पेस भी थोड़ा ज्यादा लेता है बिकॉज
हाँ.
ऑफ
टाइम
रिकर्सिव.
कॉम्प्लेक्सिटी बैड. कभी भी एक्सपोनेंशियल टाइम कॉम्प्लेक्सिटी आए जस्ट stay away from it. Okay. When the stay where like just keep in mind 2 raised to 20 you can do nothing more than that. Okay. So this is the limit approximately because if you do 2 raised to 20, 1, 2, 3, 4, 5, 6. 2 raised to 20 you can do easily with थोड़ा अंदर का थोड़ा ऑप्टिमाइजेशन गंदा हो जाता है.
बट 1 ही 9 तक चलता है ना, ये तो 1 ही 6 है.
हाँ हाँ बोलता हूँ. 2 raised to 22 is 1, 2, 3, 4, 5, 6. Right? 4, 1, 2, 3, 4, 5, 6, 7. And 5, 1, 2, 3, 4, 5, 6, 7. 5, 7, 6. हाँ, मतलब 6, 7, whatever. But just just keep this number around 2 raised to 22 or 2 raised to 20. Why am I saying that? It's because it's not always just 2 raised to 22. There is some overhead to recursion. There is some like you not usually just have one transition state, right? You have more than one. Like for example, 3 हो गया वैसा, 3, 4, whatever. So ये base is approximately 2 raised to 20. Like if you have 22 states, you can do it. 20, 22. ज़्यादा होता है, usually TLE आ जाता है. Like there are some cases where it won't TLE, but in general, rule of thumb के wise 20, 22 तक चल जाएगा. Pure recursive solution. Cool? Hello. So what am I saying is 2 raised to 22 is basically my time is 2 raised to n. Okay. Abhi n 20. Have you ever seen this in a code forces contest? N less than 20, n less than 25.
No.
Exactly. ऐसा आता ही नहीं है. Usually, like there are some states where 50 आ जाता है. There are very good problems where the constraints are very small, but the question and the level of the question, the entire implementation is very difficult. So there are questions where like less doesn't mean easy, but yeah, recursive, you can just assume it's recursive usually with less functions. Unless it's like the if you're thinking of factorial, then even 20 won't work. You will like 10 factorial is 1, 2, 3. 10 factorial is a limit usually. 10 to 11 factorial is limit if your thing is factorial. So time complexity wise, factorial is worse, then comes this, then comes everything else. So problem with recursion is the time complexity is very bad. So that is solved by DP. Okay. Only downside, usually it time pump complex. If you save time, usually what happens is space complexity increases. Like obviously, then you can optimize later, but in general, TC and space complexity. If you're saving this, usually it is in the cost of time of space. Okay. But that space is negligible compared to the time you're saving. Good? Yes, no. Now, yeah. So how does DP work and why is it useful? In factorial of n, what is happening? Wait, I'll just write this. Factorial of n minus 1. Factorial of n minus 2. So on till factorial of 1. Right, this is the base case. This is your path. Yes, no.
Yeah.
Yeah. Now, in the thing I had done, like if I give you test cases and stuff, and I give you, okay, give me factorial of 2, give me factorial of 4, give me factorial of 5, whatever. Won't this run every single time? Correct. Let's say I give you factorial of 2, then factorial of 5, then factorial of 6, of 10. No, wait. पहले 10, then 2, then 5. 5 to 10 पकड़. If I do this, this will run 10 times, this will run 2 times, this will run 5 times, correct? Like the entire loop. In factorial is not 2 raised to n. My bad. Factorial is just n. I was just time complexity. Factorial is just n by either I don't know what went into my brain, but factorial is just n, but what is happening in factorial, I'll then generalize in DP. So why should I calculate uh, like factorial of 2, factorial of 10? If I know factorial of 5, like let's say I've calculated factorial of 5. Okay. Now when I'm calculating factorial of 5, I calculate factorial of 5, 4, 3, 2, 1. Correct. Now, shouldn't I make these my base cases now? Like in recursion, what we did? A base cases, I already know what to return. Now, if I already know like if I know these answers, shouldn't I make these my base cases? Yes, no. Hello. बोलो भाई. Huh. So now, since I've calculated this, I calculated this, then store it. That is the entire idea behind this. And also add an extra base case. So that is the entire logic behind dynamic programming. You can summarize it in these two words, in these two sentences. Okay, recursion is too time heavy. What do? I store the states and I add a base case. That's it. That is how you convert usually any recursive state solution into dynamic. I just add another base case and I store the answer. So that is why since I'm storing, that is where this happens. कि space थोड़ा ज़्यादा ले लेता हूँ. Make sense? Yes, no? Yeah. So now why is this helpful? Now why does this work and why is this very useful? Now let's take this example only. This one. Okay. Here, this is a path, correct? No, I'll take a bigger example तो थोड़ा अच्छे से दिखे. Let's say this is my goal once again. This is my start. I don't have any blocks. Okay, there is no blocks at all. What will my recursive solution do? It will go to this path. It will go to this path. It will go to this path, this path. It will go to all different paths, all the paths possible. Correct. And then it'll keep on adding one every single time, right? That is the entire idea of recursion solution. That is why that is why I'm removing the zero wala state. That is why I'm doing this. Visited one and visited zero. Correct? Yes, no. Hello. Huh. Now, in DP, what do? I, if I've calculated, I store and I add an extra base case. So now, let's imagine I am at this cell. Okay. I have this path, I have this path, I have. Huh. Okay, wait. Let's add a block over here. Just okay. Now, if I have this, if I'm at this cell, okay, there is only one path forward, correct? Since I only come at this cell from this point, right? Yes, no. Hello. So now, iska answer, can I just store, like, since it's a one over here, there's only one path which leads to the goal. I'll store it. Well and good, right? The same thing. So now when I'm over here at this cell, I go here. I don't need to go to the goal. I know there is only one path, so I store it one over here. Same thing. When I'm over here, I obviously check this. I check all the other paths. But when I'm visiting this cell, I store this answer. So at the next time when I'm at test, I just return whatever, five, whatever. Now this is kind of like technically the recursive solution, this solution. You not only need to store this cell थोड़ा ज़्यादा complicated हो जाता है, but in general my logic is if I've calculated this answer completely, I won't visit that cell again. That is my entire idea behind DP. Okay. So now to further strengthen your DP, I'll view the syllabus only. So thoda, where is DOA? Yes, this is your fourth sem DOA. Abhi, your syllabus, I don't know, I don't have it. But these are the topics you have. Like, for example, in backtracking, oh, last module, huh? Backtracking, and queen is the first problem. And I suggested, not that and queen is some subsets, graph coloring, all the thing. Everything, if you like, think of it in the way I told you, ki base case transition, huh? Everything will seem easier. But main thing, college-wise, if you're writing the code, teachers might not understand it. In practicals, you can do whatever you want. Code, ठीक है. In your paper, I suffered, so I am telling you. I would suggest sticking to whatever the book says or whatever your ma'am has said in the PPT. Just memorize that because you won't get marks. I myself didn't get marks, even though technically my code was correct. Okay? तो वो थोड़ा है होता है. Because some characters, even though they have an idea, they have hundreds of papers, 200s of papers, they won't check line by line if your code is correct. They'll have a template. If it is matching with the template more or less, then they'll give you marks. Like probably some teachers will go to the board, but in general, I would just assume worst case they don't know coding. They just have the template, so it's better to stick to the template. Okay, that is an advice. But yeah, now yeah, very important Fibonacci problem. Same thing, same thing as factorial. Fibonacci is what? Sum of two previous. Okay. So how would you write a recursive solution to this? Can anyone tell me for a Fibonacci? Just a normal recursive transition state or what you return. Hello. Like if I ask you what is Fibonacci of n, what do I what do I get it? What do I get it from?
Fibonacci of n minus 1 plus n minus 2.
Exactly. Fibonacci of n minus 1 plus Fibonacci of n minus 2. Fair enough. How will this tree look like? I am at n. I go to n minus 1. I'll also go to n minus 2. I'll go to n minus 2. I'll go to n minus 3. N minus 2. I'll go to n minus 3. I'll also go to n minus 4. And so on. Correct? Let's say n नहीं पकड़ लो 4. Okay, so 4 goes to 3 and 2. 3 goes to 2 and 1. 2 goes to 1 and 0. This goes to 1 and 0. Fair enough. So that is my entire tree. But now what do you see over here? Once I've calculated 2, I'm once again calculating 2. Once I've calculated 1, I'm once again calculating 1 and stuff, right?
We store the values in an array.
Exactly. So that is the entire logic DP. I store it, add a base case. So if I was to write Fibonacci, obviously base cases, if n less than equal to 1, return n because Fibonacci of 0 is 0, Fibonacci of 1 is 1. I'm assuming like that. And I return fib of n minus 1 plus fib of n minus 2. Now this recursion solution, recursive, this is 2 raised to n. Okay. Because in general, I am having two branches and I can have n different branches, so 2 raised to n. Now, in DP, what do? I just store it. I also pass a vector of, let's say, Fibonacci. I can have a global vector, whatever. Now, same thing. I'll just copy this, okay? But now, what do? Add the extra base case. Now, first let's add base case that if Fibonacci of n already calculated. How do I check if it is already calculated? In the visited thing, I can just check 0 or 1. But in this, I can initialize Fibonacci as n comma minus 1. Since I know Fibonacci cannot go negative, that is what I initialize it to. So always initialize to a state not reachable. Like usually it is minus 1, but some cases, a lot of cases where minus 1 is also a valid state, that is where you don't do it minus 1, you store something else as the initialization. So over here, minus 1 is the base like initialization. So here you return that directly. Okay. And here that is add base case. what is the next step? I need to store answer, right? So in storing answer, you can do it like this. You can do this, or the easier way is this is store and return. Make sense? So that is how you convert any recursive function. So I'll just write down the steps so you can just think of it like that. Okay. Any DP problem, like most DP problems, steps to solve. First, write recursive solution. Step two, make storing array initialize to state not reachable. Third, add base case. Fourth, store and return. That's it. That is the entire gist of most, if not all, DP problems. Make sense? Yes, no.
Yes.
Good.
I
So
had one
now,
question though.
hmm, bolo.
In the Fibonacci one,
Yeah,
why do we can we not build the solution from 0 to n?
yeah, yeah. So that is what, yeah. So that is a valid point. And another Fibonacci, Fib, let's say. What you can do is vector ll a f f dot pushback 0, f dot pushback 1, and then for equal 2 to n, f dot pushback f of I minus 1 plus f of I minus 2. Correct?
Yes.
You can just do that and then return f dot back. That is fair. But that is like this is what it's called iterative DP.
Okay.
Okay.
Okay. I
So
got it.
you're using for loop. You can also now then the next step comes optimization, space optimization. Because now you've efficiently done the time, but space optimization, if you can think of it as a equals 0, b equals 1, c for LLI equals hmm, c equals 0 पकड़ लो for LLI c equals a plus b, no, b equals c equals a plus b, a equals b, b equals c. Now then you can return c. This is space optimization. You don't need the space of n.
Okay.
Okay. So those are the steps. But in general, usually in competitive programming, there is usually no difference between iterative and recursive DP. Like when the time limit is very strict, then you might have to write iterative. But in general, most of you, till you reach expert, I am for sure that you don't need iterative. You don't need iterative DP. If you can do a recursive DP, fine. Like it'll pass. It'll give you accepted.
Okay.
Good. So yeah,
Iterative DP then starts from the base case.
yeah. Iterative DP, it starts from base case. And one more thing, this is called bottom up approach. You'll hear this term said by teachers, by everyone. And this is top down approach. I'll also give you a template to convert a recursive to iterative, but that I'll tell you later because abhi karke it's no point and yeah, like, it's better to move on to some other problems, right? Fair enough?
Yes.
Yeah. Now we've done Fibonacci. Let's do coin change. What is the coin change problem? A very coin change one. I can just search it over it. Tags निकाल दो. Hi. Lead code coin change. So you're given integer array of coins that this coin, I have a 1 rupee coin, I have a 2 rupee coin, I have a 5 rupee coin. Return the fewest number of coins that you need to make that amount. Amount is given to you. So now I have coins, I have amount. I want to return fewest coins required. Right? So how would I write a recursive solution to this? Can anyone help me out? I'll have a wait. Now let's move on to coin change. Vector. What is my base case? Hello. Since I want to make that
Base
amount,
case
what
will
is
be
my base
one, right?
case?
Base case will be one.
One?
Uh,
Are you sure? Like I can have two also as an amount, for example. कुछ भी. My coins are not fixed. Coins can be variable. Amount is also variable. Can I always make a amount of one? If I don't have a one, what do I do?
it will be zero then.
Exactly. Zero or negative.
Zero
Right.
negative.
Base case negative is also a case, right? Technically. Either you can handle it here or you can handle it during your transaction, whatever. If amount less than zero, return zero, return 10,000. Why am I writing 10,000?
It's an unreachable solution.
Exactly. Unreachable solution. And at the end, I want to minimize, right? If I do zero over here, won't that be the minimal answer?
Yes, infinity is also an option.
You can do infinity, but one thing to notice, it's usually better to do it 1e15 because if you're adding stuff, if you're adding infinity plus one, infinity plus infinity, you will go to overflow and you might reach negative numbers.
Okay.
So a very good rule of thumb is always make it something which is addable but not reachable. If you're not at all doing additions, then 1e18 infinity works. Okay. If amount equals zero, then I return zero. Correct?
Yes.
Yeah. Now, now I have left with transition states. What are my transition frames?
We will be iterating through all the coin denominations, right?
Exactly. In recursive solution, I want to do everything, right?
Yes.
So for auto coin in coins, I'll have an answer. Same thing, 1e18, 1e15. Now, answer is min of answer, comma. What is my transition? What do I move on to?
Could you show the code again once again?
Yeah. I want to minimize the number of coins. So what do I return? I return the number of coins, right? How do I change this? How do I go to the next state? Cool. No issues. I'll help you out in this one later on. सब आ जाएगा. Now I'm using a coin, so my answer increases by one. Yes, no.
Yes, got it.
Huh.
1 plus 1.
And what is my next state? My coins remains the same, but my amount changes, right? Amount gets subtracted by the
But number of coins.
coin, that value,
Yes.
correct? And I return the answer. So this is recursive. Time complexity, a lot. It is number of coins raised to n, whatever. बहुत सारा thing, right? Now how do I DP it?
Array, store it in an array.
Exactly. So I'll have vector element. Usually you just write it as DP. Now what do I add? Firstly, I add it to my base case. What does this become? If DP of
0, 0 will be 0, right?
amount, not zero. Zero technically, yeah, zero is also not achievable. You can do zero or once again 1e15, whatever. Correct.
Yes.
Return DP of amount. Fair enough. And over here, I store and return. That is it. These uh, three changes to your code and your two changes to your code, and you've optimized it. You've TC exponential and iska TC is O of n. What is the time constant? I'll come to that. But yeah, simple as that. You've converted exponential to O of n by just doing this. Make sense?
The general, I have written this code. What is the difference in your code and my code?
You can just, yeah. Huh. Your code is iterative. That's it.
But you have used a recursive function in it, right?
Huh.
Though it is being checked directly into the array, you've written a recursive function.
Exactly. So that is the like the entire difference is this is DP recursive and DP iterative. Once again, it is bottom up coin search. Same thing. DP of 0 is 0 for and
Oh, पूरा code नहीं आया. 1 second. I don't know why.
I'll just copy paste this. And this should work kind of. Hmm. So I go to all the amounts, and what is this doing? And so that is what I'm saying. So see, in this there are two for loops, and you don't like, it's not O of n, it is O of amount into coins, whatever. थोड़ा complicated. Oh, amount into coins only. So, so this and this, the time complexity is same. But now what he is doing over here is instead, like, what am I doing over here? I'm going to a lesser amount from a higher amount, right? I have some amount X. I'm going to X minus coins. Okay. So from what he's doing is I'm going from an X minus coins to X plus coin, kind of. No, same thing only. So now I am fixing coin over here. The I is the amount, current amount. I'll also explain it thoda in depth because this is thoda iterative, is thoda visual, and you can visualize this. It will help you if you are able to visualize. But yeah, current amount. I go to all the coins, and if it is valid, you can do this or I minus coin greater than equal to 0. Then I can do this. Make sense, Sayuj? So that is your code. That is how you visualize. So now how does this like yeah? I'll explain this part and I'll explain each step by step. Okay. Now coin change, what recursive does is I have the final amount. I go to a minus c1, a minus c2, a minus c3, and I'll tell you how this optimization works also and what the time complexity does. So now here same thing I can do a minus c1 minus c1, a minus c2 minus c1 minus c2, whatever. And over here also I'll have a minus c2 minus c1. So what do you see over here? This is repeated. So I stop over here itself. I have calculated this, then I stop. If I have, let's say, C1 minus C3 once again, and this also has, let's say, C1 minus C3. I've calculated this, so I stop over here. So I just calculate these parts only. So what is happening is, now how do I measure the time complexity? How do I know that it will fit in my time complexity? That is a very important thing. There is a very straightforward formula. TC is 1 plus transition, no, 1 plus number of states or size of DP array. क्या था? I'm forgetting. Transitions, no, 1 plus state of DP array into transition states. Okay. So over here, what is my size of DP array? Amount, right? This is N. What is transition states? Size of coins, which is M, right? That is why it is N into M approximately. Make sense? Yes, no?
Yes, it makes sense.
Huh.
In
Now,
my code, it is basically every amount calculation we are multiplying by the number of coins.
hmm. So over here, you can just look at the for loop and say it is n into m because this is amount, this is the number of coins. That's why n into m. Correct.
Yes.
Now, how the iterative solution works is iterative solution works as a table. Okay, actual table, actual array. Now, let's say I have 1, 2, and 5. Okay, 0, 1, 2, 3, 4, 5, 6. This is initialized to 0. Now, when I'm at 1, I subtract all the coins and check if it is inbound. Is 1 minus 1 of inbound? Yes. So I require 1 coin to this. Correct. For 2, what is it? I can subtract 1 coin. So I can have the 1 plus this plus 1, or I can subtract a coin of denomination 2. So plus 1. So what is a minimum? 2 or 1? I store
Zero. It's
1.
a zero. One. Yes.
Exactly. Now for the state of 3, I go 1 behind and 2 behind. Whatever is the minimum, I take. So
Both
1
are
plus
two.
1 is 2, both are 2, so 2. Same thing, 4 के लिए I go 1 behind which is 3, 2 behind which is 2. So this is 2. 5 के लिए 1 behind is 3, 2 behind is 3, 5 behind is 1.
One.
And for 6 is also 6 is 2 now, and so on. That is how you build the iterative solution. You just keep on going behind and take the minimum. And recursive is let the recursive function do the magic. I'm just going 1 behind. That's it. The benefit of recursive solution is I just care about one state behind. I don't know how the one state behind is getting calculated. It is getting calculated by magic. I have this base case. It is reaching this base case. But I don't need to think about in terms of for loop. I don't need to think about in terms of how this state gets the value from this all possible states. Why am I saying that is? There are in a 2D DP, I have a grid. I have a table basically. And let's say I am taking this value from here and here. Okay. So here I need to build this array. I need to have this base case. And then I go up and I check up and left. Okay, that is in a normal DP solution. There is a question or there is a part of your question. Okay, I'll come to that. But in recursive, what do I do? Okay, well, I am here. I go to this, I go to this. I don't care how this is getting calculated. I don't care how this is getting calculated. It is getting calculated by magic. That is how I think of it. Recursion DP handles everything for me. I just need to make sure key it is correct and it is within my time limit. That's it. That is the benefit of recursive DP. कि अभी तो let's say 1D you can visualize. 2D also up to some extent you can visualize. What if I have 5 states? How do I visualize this? How do I even think of this? Recursive is no visualization. Just think of कि from this state, where do I go to the next? That's it. That is the strength of recursive DP. Does it make sense?
I
I know.
think so. Jen, could you share your CPP ka code?
This one.
This one. The recursive one. Recursive.
I'll share it in chat. I'll also. हाँ, I'll share it in chat and जो भी है बोल दूँ.
received.
I'll also have the document में भी update कर लूँगा जो अपना है ना with
Okay.
the templates and shit. Good question. I I close the tab. Hmm. So now that is coin change. Next question is 01 knapsack. 01 knapsack. You can just once again do lead code knapsack. अरे ये नहीं. अरे किधर है क्वेश्चन? नहीं. Hmm. So you're given weights and values of the items. Ah, wait. One more thing, a very important thing. In coin change, you might think, why not I choose it greedily? Okay, let's say I have amount 11 and I have coins 5 to 1.
Greedy
What if
works
I,
for only certain solutions,
huh,
specific
what
solutions.
if I choose 5 till I can choose 5? So I take 2 coins of 5 and then I take 1 coin directly, basically. I keep on subtracting the largest coin which I can take till I reach 0. But now the problem is, let's say I give you the coins 1, 5, 6, and 7. Okay, these are my coins and my amount is 11. Okay, if I choose greedily, what is 11 minus 7? 4. I have to take 4 1 coins, like I'm forced. So I'll have to take 1 into 7 plus 1 4 into 1. Correct. I'll have 5 coins. But you can see I can use one 5 ka coin and one 6 ka coin to have to use only 2 coins. So the optimal solution over here is you won't get with greed. So usually in a question, if you see a normal question, the first instinct where every one of you will have, like even I have, is why won't I choose greedily? But yeah, so whenever you're looking at a question, a new question, you don't know if it's greedy, DP, whatever. If you can't think of a lot of things, greedy mein there are a lot of cases you have to make sure ki it will work with the greedy, right? If you can think of a DP solution and it fits into the time and space complexity, always do the greedy solution, a DP solution. Irregardless of if a greedy solution works, if you can think of a DP solution and it fits in the time constraints, do the DP solution. No, you for sure know that it is correct. DP ka main benefit is optimality. So DP का main benefit is DP optimality. Like if you've written the cases correctly, it'll always return an optimal solution. So if you can think of an optimal solution with DP, do DP. Don't get a WA if greedy was not possible and you wrote a greedy. Make sense? Obviously, if you know for sure कि greedy chalega, then yes, greedy will work. There are like there is this thing called exchange argument. greedy exchange arguments. You can look at it. But basically, for to prove a greedy solution, why am I saying it like this? Is because till now, I know I had, and most of you might have had, while solving a question, if greedy solution strikes, you will submit it. If it's AC, it is AC. If it is not AC, you try to debug and just do whatever. If you don't know DP, then you're just good. But it's okay. But if you know DP, you'll try greedy. If it doesn't work in TC, like the test cases fail or you get a WA, then you think of a DP solution, right? That is a that will work till specialist, that will work till expert, because usually the A div 2 A div 2 Bs are greedy only. Like usually they don't care about DP. But yeah, it is a very wrong thing to do. I am also suffering from that because now I get a lot of WAs because I think of greedy first, or I don't prove my solutions. So proving a greedy solution is very important if you want to advance to, let's say, higher rated like CM, Master, X, International Master, whatever. Proving is a very important part of the entire problem solving. So there are to prove a greedy solution, exchange arguments is one way. There are more. There are three, four ways to do it. But yeah, if you in your rating, I would say if you can't prove and you think greedy will work, submit it. Fine. But try to, since you now know DP, very basic DP, try to fit in a DP solution. Who knows? It works. And it'll be lesser strain on you also, right? Because in greedy, what do you do? See test cases, try strategies. If works, code. In DP, write recursive. If you've practiced recursive a lot, this will be very easy for you. I take less than 5 minutes to write a recursive solution, actually to write the entire DP solution. But yeah, that comes with practice. So write recursive, like very simple, obviously, it depends on the implementation also. And
General,
then
right? Practice
store.
recursive questions.
Yeah, to practice recursive, just lead code is more than enough.
Uh,
Like,
Specific, like, is there any path or track? Like,
I
I'm just
think there is a track in lead code also. Wait, I'll problems. You can obviously just do this, just filter by tag,
do I filter recursive or do I filter DP?
recursive. Just try it, just solve all easy, mediums, hards also try.
Also,
Not
is
only
all
this,
recursive solvable by DP?
no, all recursives are not solvable by DP. I'm saying practice recursive first.
Okay, okay.
Make sure that recursive you're full on with. Huh. One more thing, why is not all recursive solvable by DP? I'll come to that a bit later. Okay. And if
Okay.
you want to calculate deep, if you want to practice recursive DP specifically, you can just do this. Most most questions will be solvable by anything. Like, let's say I have done, for example, just pick this question, house robber, submissions. This I have done space optimized. My first solution was recursive. Then I tried iterative. So that is how I practice on lead code, because in interviews and stuff, it is very useful. First write recursive, then write DP, then write iterative, then write or space optimization. That is the Striver way to do this. And I myself learned a lot from Striver. So yeah.
Okay.
if you can think of iterative, you are way ahead of even me also, because iterative I can't directly think of it. Like some questions I can think of it, but most I can't. So, yeah. So think of
The next
iterative is
question.
very good. Don't worry. Yeah, cool. Now coming to the knapsack. I have weights and values. I need to put these items in, like, basically it is a house robber problem only. Wait, no, no, not house robber. Sorry. Sorry. So knapsack question is, I am a robber. I have I, let's say I can hold X kgs of items. Each item has value and weight. I need maximum value. For example, I want to rob a house. I want to I want to get I want maximum value. The weight doesn't matter, but I have a limit on how much I can hold, right? So that is knapsack. You can think of it uh, in terms of time also. For example, I have specific amount of time. I want to solve the most important problems or whatever. Let's say I have in CP terms, I have 2 hours. I have 100 problems, each with rating, each with rating and time taken. Solve A, most problems, and B, most total rating. Most problems I can do greedily. Most rating I can't do greedy. Total rating I can't do greedy. Same thing, you can make a counter case to this, and that is where DP comes in. Okay, so how do I get this maximum value? Maximum value, no? Total maximum value. Okay, same thing. I'll knapsack.
There will be also only one dimensional DP array.
Yeah, yeah. So now, firstly, what do I have over here? Vav vector LL weights, vector LL values. Now it's have it. Now, if I want to write recursive, what do I do? Now that is a very this is a very standard this is a very standard problem and kind of a new idea for you if you might have not seen it. But in general, the logic is in recursive. I either take this value or I do not take this value. So it's also called a take not take DP or O1 DP. 0 1 basically 0 is I take, not take, I 1 is I take. Okay. In recursive solution, I just write this out and then you can help me optimize DP it, okay? Because it's kind of a new idea. Base case is if I equals wait, base case wait, and I have sac. Okay, how much weight I have left. If sac is less than 0, return manufacturing obviously. if stack equals 0 or I equals weights dot size, then I return 0 because I've reached the end of the items or my sack is full. Either or. Now what do I do over here? Transition for a now. Transition is simple. I take. Take is what? If I'm taking this item, I'll add the value of that item. Yes,
And subtract it from the sack.
exactly. I've gained this value. Now the next state is what? Knapsack weights values I plus one. I move on to the next element, and my sack gets reduced by
Weight.
weights of I.
Weights of I.
Okay, and not take is I don't gain anything by not taking, right? Weights values I plus one, and sack also doesn't get changed, and I return answer. Correct. So this is a very standard thing. You take and you not take. Usually, it is preferred to do not take first and then do the take. Values of I. Why am I saying this? Do not take before is usually in the take you have some if conditions, some base cases, or you're looping over the take condition. There'll be multiple takes, for example. So, but not take is just a simple state. So always do a not take first because that is a very easy line. Yeah. Now, how do I store this? How do I convert this to a DP solution? Cool. So over here, now one main thing in a DP, when I'm converting recursive to DP, I store what is changing in my states. If I'm moving from one state to the other, in the coin change, what is changing? Only the amount value is changing. Correct?
Yes.
Over here, what is changing?
Oh, values. The weights. The sack is changing. Sorry.
Sack is changing and my I is changing, right?
Hmm.
So over here, I need a 2D DP. Now, now what do I do? I have this DP. Now, what do I do? Now, what do I do? Can you tell me?
We will store the values in the DP array, both weight, both I and sack.
Exactly. So now DP I comma sack. If it's already computed, this is what not equal to -1 because -1 can't happen. Return DP of I sack. And here I just store it. That's it. Makes sense?
Yes.
But now,
We have to minimize the value, or we have to minimize the
I don't
value.
know, I want to maximize the value. My bad. So that is why it is 0. -1 if 15. That is a base case. Fair enough? I was just stupid. Yeah. Yeah. So in this DP, that is why if you see constants are 1e3, 1e3. That means n square will work. And what is my space over here? 2D DP. I is what? I is I is number of items, right? Which is n. Sac is any weight, which is W. So my TC is n into W. And if you look at the formula also, where is it? Hey, magic, it is gone. So TC is basically 1 plus the number of states, which is the DPRF, into transition. What is my transition? There are only two states, so it's 2. So that's it. Make sense? Yes, no.
Yes, I got it.
If you um, huh. Now you can technically optimize this further. And yeah, थोड़ा सा. Hmm. So that is it. Then that is knapsack. So in general, what type of DP have you learned? First is
Minimizing coins.
coin change or Fibonacci, same thing only, no? Technically, are they of the same class?
Yes.
Because it is like one value is changing. So technically, these two, you can say it is the same. You have some transition, one value changing. Okay. And second is knapsack. The types I'll do, but second type is knapsack or take and not take. Take not take is a very standard, very useful thing. A lot of code force problems which are around 1500 can just be solved by take not take DP. Over here, I have this sac value, right? उसके ऊपर it is dependent, for example. But there are a lot of take not take DPs where only I changes, nothing else. I might have solved it also. I don't remember it. Problem set. Tag DP. uh, थोड़ा सा easier जो किया हो. Did I solve it with TP? Um, no. But yeah, इसमें ही हो जाएगा. Whatever. Regardless, this is a very common technique. Take not take DP. All you need to do is in your DP, you store n. Okay, and then if extra needed, you store that also. Transition from the name itself, take the element or not take the element. Alternate question to this knapsack problem. is I have I have some numbers, okay? Numbers given. Make sum of x. Okay.
Jen, I had one question.
Huh.
वो knapsack में I is basically iterating up till amount, right? Not
Yeah.
iterating, but going
You
up
go till the n, basically.
n, हाँ, n. Okay,
मतलब basically weights dot size.
okay.
So over here also, if I have a set of numbers and I want to make a sum of x, so over here also I do the exact same thing. So here I don't need to count the numbers. I just want to check if I can make or not. Okay. So same thing. It is deep knapsack only. I take this number or I don't take this number. That's it. And my x changes. Make sense?
Yes.
Hmm. Now, how's it? This is house robber is another example. Now, I just I just let you read and you tell me how to solve this. Each house has a certain amount of money. Now, if I rob two adjacent houses, I will get caught. What is the maximum amount of money I can get? Basically, I want to rob the most house. I want to get the most money, but I can't rob two adjacent houses. How will I do this? It's pretty similar to what we have done already. हेलो बोलो भाई तरण बोलो सार्थक बोलो एलन बोलो
ये काइंड ऑफ मैंने एक बार पहले देखा हुआ है तो मैं नहीं बोल रहा इसलिए।
अभी बोल दे कोई और
अच्छा,
कर नहीं रहा तो फिर बोल दो
हाँ तो डीपी ऑफ x माइनस टू एंड x माइनस थ्री है, मतलब हम लोग x माइनस वन तो ले नहीं सकते इसलिए द मैक्स ऑफ डीपी ऑफ x माइनस टू एंड x माइनस थ्री।
okay in terms of recursive
हाँ
here like same thing let's just do this copy this house robber here I have just vector ll sack I don't have now I just have houses now either I not take is this sack doesn't matter huh? Uh, okay, I don't know why it is getting houses of right. Okay, so that is the entire code for this. कि now simply I just take this, I rob this house, अरे wait, and I go to I plus 2 over. If I'm not robbing this house, I can go to the next house. I can go to the next house very easily. But if I've robbed this house, I don't go to the next house, I go to the next to next house. That's it. Pretty simple. So usually like that is how take not take works. Ki either the constraint is on the consecutiveness of the taking, or it is the constraint is the total number of items you can take or whatever. So that is take not take DP. And that is over knapsack. You can use the table set method like in table form, knapsack is like this. Like that is how they'll teach you. And so basically, if I am at this state, I want to, I am at this. Basically, I am at index 1 and sack left is 5. So index 1, so I'll take, wait, huh. So yeah. So not, either I've taken the first element. If I've taken the first element, let's say this is it. Weight is, wait. Weight is 1, 5, 2, 3. Value is 4, 4, 4, 5, 5, 6. Okay. Now if I'm at this state, I've either taken, so my value comes from this or my value comes from this. Right. Not take मतलब जो भी sack था, the same sack remains, or I've taken to my like I get something greater. Or you can do reverse also, like starting from 0 you can do, that is table iterate. Okay. So, yeah. Now these, the graphs and all pair shortest paths, what is that? This part will be covered by Dhyanesh because that is it. And now matrix chain multiplication and LCS. I'll just do, I'll do this till 5, then we'll move on in the next DP session.
क्लास कितने बजे तक है अभी?
5 बजे बस, मुझे
अच्छा
भी जाना
हाँ चलेगा.
है. So now yeah.
नेक्स्ट टाइम से प्लीज क्लासेस थोड़ी छोटी छोटी कर सकते हैं क्या? क्योंकि लाइक
हाँ हाँ.
एक एक घंटे में याद रह जाता है, वो एक ही
अरे
बार में
एक,
सब कुछ हो जाए. हाँ
हाँ पता है. I wanted to take only recursive, but then since अभी DP आ ही रहा है and like ध्यानेश भी थोड़ा ग्राफ में जाने वाला है, तो मैं I want to take DP, but recursive since बहुत important है, तो recursive थोड़ा किया, वरना
अच्छा
it would have been like 1.5 hour session. Yeah.
ओके.
हाँ
एंड ये क्लास के पता 5 मिनट फ्री हो क्या? एक क्वेश्चन
हाँ
था
हाँ
लाइक ये कॉइंस वाला.
हाँ हाँ. Now matrix chain multiplication अभी नहीं कराते. I'll just do LCS now. Yeah. So now let's say I have a string A, B. This is a different type of DP. Wait. A, B, 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 C, D, E, A, B, G, D, O, T. अरे wait. मैं क्यों कर रहा हूँ? Lead code LCS. हाँ. So I have this. अरे यार. Bad examples everywhere. अच्छा वाला कुछ नहीं है. हाँ, and ACE. Okay. What is the longest or common subsequence? Basically, subsequences, uh, if I delete some characters, ACE is a subsequence. If I delete E, ABCD is a subsequence. If I delete B, ACDE is a subsequence. That is a subsequence. And I have string 1, string 2. I want to calculate the longest common subsequence. Common in the sense, दोनों में same subsequence होना चाहिए, but that was the longest. So how do I do this? Now over here in take not take, like it is a part of take not take only technically. Like it can be solved using like kind of take not take only. It is take not take in general. But yeah, over here in take not take, what are we doing? We're iterating over numbers, right? Iterating over values, over indices, correct? Yes, no. Huh. So we're iterating over indices. So I'll need to store index of I, index of j. When will I take? Take as in I've added something to my subsequence. Hello. बोलो भाई. सार्थक, Alan, Sayuj, Dhiren. When will I take a character into my subsequence?
ये वाला जस्ट अभी देखा. This is basically अगर दोनों कैरेक्टर सेम है तो it would
Then
be
only I'll
DP
take,
of.
no?
हाँ हाँ,
हाँ,
then only
हाँ,
you'll take.
रुक. Step by step.
Okay.
Step by step. हाँ. So now if my S1 of I equals S2 of J, then only take. Correct? Now if I'm taking, when taking, अरे, why am I? When taking, what is next take? I've taken both, no? So I can just do I plus 1 and j plus 1. Fair enough? Yes, no?
Yeah.
And now one other thing, if I'm not taking, I'll have three different states. Either I don't like I move on to the next character of both the strings, or or I keep I but I increment j, or I increment I and keep j. These are the three not taking steps. Why? Take the string only, for example. I'll take. So I'll move this pointer. BC. If I move on from C, if I just like let's say I increment both, will I be able to match C and C? No, right? But if I keep this pointer at keep J at C and move I get to match CC. So that is why you want to go to all the possible states, and all the possible states happen when these three things happen. That's it. Fair enough?
Yeah.
And yeah. So if you want to see the code, my original submission will be अरे नो रिकर्सिव हाँ नहीं ये भी रिकर्सिव नहीं क्यों है अरे हाँ ये रिकर्सिव हाँ फंक्शन सो नाउ अरे छी क्या गंदा लिखा LCS is basically LCS I J vector ln dp. Correct? Array wait, I'll also have string and s, string and t. Let's say. If what is my base case over here? If either of them is at the end, I can't do anything, right? Uh, j equal t dot size return 0. Another base case is the dp case. dpij not equal to -1 return dpij. And wait, सब जगह ये किया है, अच्छा not equal to 0 भी याद आया and not equal already calculated is were not equal to the basis. हाँ डालना पड़ेगा. Yes. Now same
If S of
thing.
I equals S of J.
हाँ take wait firstly answer equals 0. Take is if s of I equals t of j, answer equals 1 plus LCS I plus 1 j plus 1 dip sj also obviously st. Now then I have not take. Same thing answer is min of answer comma LCS st I plus 1 j plus
So
1 dp
longest.
I plus 1 j dp. अरे max हाँ st I j plus 1 return dpij for answer. That's it. So in a take not take dp, what you do? Base case, write not take first or take first, whatever, and return the answer. Now, one thing to notice, technically I'm writing this twice. This entire state. I'm writing this twice, but it doesn't really matter because वो store हो रहा है DP में. So time complexity remains the same and into M ही रहेगा. Fair enough? So yeah, that is it. That is LCS. Now, for matrix chain multiplication and TSP and stuff, we'll move on to the next part. And next DP session, थोड़ा सा and we'll move on to थोड़ा more different cases of DP also कि अभी अभी तो सिर्फ take not take and normal storing जो किया है in general. This will be helpful for you like till 1400 problems, 1400 1500 code versus problems. You won't require more than this. So you're well and good for this. बाद में थोड़ा हायर रेटेड थोड़ा होंगे थोड़ा डिफरेंट लेवल ऑफ डिफरेंट काइंड ऑफ प्रॉब्लम्स आता है तब वो आता है बट ऑलवेज मेक श्योर डीपी में कि तुम्हारा टाइम कम्प्लेक्सिटी थोड़ा अच्छे से कैलकुलेट करो कैलकुलेशन इज बेसिकली नंबर ऑफ स्टेट्स ट्रांजिशन उतना होना नहीं चाहिए इफ यू ट्रांजिशनिंग मल्टीप्लाई दैट्स इट कूल दैट्स इट दैट इज रिकर्जन एंड डीपी sayonara bye bye